In this short demo, I will show you how to use FauxPy, a fault localization tool for Python programs. My name is Moreza Alipur and I am the developer of FauxPy. So in order to use FauxPy, first we need to install it. You can install FauxPy using this command, pip install FauxPy. Now FauxPy is installed and we can use it. But before that, let's take a look at this example that I've prepared for this demo. So in this example, we have two packages. One of them is code and the other one is tests. In this module, in this package, package code, we have two modules. One of them is equilateral.py and the other one is isolessence.py. And we also have two test modules inside the tests package, one for each of these two modules. So inside this equilateral.py, there is a function, and this function, what it does is that it computes the area of an equilateral triangle. And there's a bug here on line 11, and this is the patch of this bug, which is commented out. So now we want to see if we can use FauxPy to locate this bug on line 11. In order to do that, we can use this command, python -m pytest, and then we should specify the part of the test suite that we want to use in this fault localization session. I'm going to say tests, test equilateral.py. Then we should specify the part of the source code that we want to involve in this fault localization session. I'm going to say package code, which is this package. The next thing is to specify the family we want to use. We want to use SPFL because FauxPy supports 4 different families. This time we're going to use SPFL. SPFL is spectrum-based fault localization, a widely used family of fault localization techniques. And we can also specify the granularity level of fault localization. I'm going to use statement. So statement level granularity means that we are going to localize individual lines in the program. FauxPy also supports other granularities like function. So if we run this command, we see that FauxPy returns 2 lists, actually 3 lists, one for tarantula, one for OGI, and one for DStar. These are 3 well-known SPFL techniques. So let's take a look at the output of tarantula. Tarantula is telling us that module equilateral.py, which is this module, has a bug in one of these 3 lines, line 10, 11, and 13, which are these 3 lines, because the suspiciousness score that tarantula has computed for these 3 lines are equal and the highest. And as we can see here, tarantula has been able to locate this bug. A user has to go through 3 statements to find it. Now let's try a different approach. This time we're going to use MBFL, another family of fault localization techniques. MBFL is based on the idea of introducing random mutations in the program and seeing how those affect the behavior of the tests. So now we have to wait until FauxPy finishes working. When we run the MBFL family, what happens is that FauxPy returns 2 different lists, one for Muse and one for metal axis, 2 well-known MBFL techniques. And here let's take a look at the output of Muse. So it is telling us that module equilateral.py on line 11, it has a bug. So it is telling us that the bug is here, which means it has been successful at locating the bug. This was a short demo of FauxPy, a fault localization tool for Python. You can find FauxPy on GitHub, and you can find the link to this GitHub repository in the description.